Let's go.
Oh, I wish I had money for a coffee. I can show you how it works. Really?
Okay, so first is the heating element, which is an electric resistance element in the H2O. It's used to heat up water for brewing in drip coffee makers. The grinder, an electric motor powers a grinder to prepare whole coffee beans for brewing. Warming plate, an electric resistant heater is used to maintain brewed coffee at a temperature of 100 and 190 Fahrenheit. So then is the electric pump, which is during the brewing process, the pump takes cold water from reservoir and injects it into the boiler under pressure greater than 100 psi. Steam 1, conduit having an air admitting inlet and air discharging outlet. The microprocessor controls the functions, pre-warming and automatic start-stop times.
Oh, that's really interesting.
Yes, I know, right?
Yeah. And do you know about like the current or voltage of a resistor? Because I have to do that for a project.
Not really.
Well, thank you.
Look. I know.
Oh my God, can you show me?
Yes, of course.
So first we have two parallel circuits that are 8, the one with 8 ohms and the one with 4 ohms, and the one with 6 ohms, 3 ohms and 2 ohms. So first 1 over 8 plus 1 over 4 is equal to 3/8. The reciprocal of that is 8/3, and that's equal to 0.266. Then we have the other one that is 1/6 plus 1/3 plus 1/2, which gives us 6/6, that is just 1. Now we have two circuits in series, which is the one with 10 ohms and 2.66 ohms, and the one with 1 ohm and 5 ohms. So in this case, we just need to add them up normally, and we end up with 12.66 ohms in one and 6 ohms in the other one. Now we have two parallel circuits again. We add them up as we did the first time, and it's just 1 over 12.66 plus 1/6. That gives us 1037 over 4222. We get the reciprocal, and we end up with 4.07 ohms. So the last part is just easy because we have two resistors which are in series, and we add them up normally, 4 plus 4.07, and we end up with 8.07, and that in ohms is our equal resistance. We want to obtain our total current and voltage in each of the resistors. So to do that, we're going to use all our diagrams, and we're going to start with the easiest one. We're going to start from the end, and we're going to go into the first one. So we already have the voltage, which is 12 volts, and the resistance, which is 8.07 ohms. We just have to divide that, the voltage over the resistance, and we're going to obtain our total current, which is 1.49 amps. So we know that when the resistors are in series, the current is going to be the same one. So we start with the first one, which is 1.5, and we give those values to the first two resistors in series. We solve with our formula, and we obtain that our voltage is in 4, 6, and in the 4.07 ohms, 6.105. Then we know that when our resistors are in parallel, our voltage is going to be the same one. So we do the same process, but now in the formula we isolate the current, which is I, and we obtain that for the 12.66 ohm and the current is 0.4822, and for the 6th one is 1.017. Now we do the same process in series again for 1 and 5, and for 10 and 2.66. We substitute our formulas, we isolate, and we have that for the 5 ohms, our voltage is 5.08, the current is 1.017. For 2.66, our voltage is 1.282, and the current is 0.482. For the 10 one, it's the voltage 4.82 and the current 0.482. And for the 1 ohm resistor, the voltage is 1.017 and the current is the same. Now we end up in our first diagram, which in this case is the last one, the original one, and we do the same with our parallel series, which is the one with 8 ohms and 4 ohms, and the one with 2, 3, and 6 ohms. We do exactly the same process. We obtain that for the 8 ohm, the current is 0.160 and the voltage is 1.28, and for the 4 ohm, the current is 0.32 and the voltage is 1.2. Now for the 2 ohm resistor, the voltage is 1.017 and the current is 0.508. For the 3 ohm, the voltage is 1.017 and the current is 0.339. And for the 6 one, the voltage is 1.017 and the current is 0.1695. Now that we have all of the data, we just need to sort out which answers in these diagrams are the final ones and which ones were just helping us to obtain our final ones. So we put a little check mark on all the ones that are the final and we put them in our table. So now we have all the information about this circuit in specific.
Oh, thank you for explaining everything.
Don't worry.